Welcome back everyone. In this video we will talk about indirect matrix solver. So essentially here we are solving the linear system of equations indirectly. So earlier we studied direct solvers, in which we studied Gauss elimination method, and then we studied the tridiagonal matrix algorithm, LU decomposition algorithm. So in this indirect method, basically these methods are iterative methods. So here we have this ax is equal to b. So somehow we will guess x, k, and then we will update it by doing some operation. So we will basically calculate xk plus 1 until mod of xk plus 1 minus xk reaches a desired epsilon, that is the convergence criteria. So suppose I have this matrix, that is this we have the system of equation as ax is equal to b, where the matrix A is given as a11, a12, a13, going up to a1n, a21, a22, a33, going up to a2n, and then we have this am1, am2, am3, going up to amn. So this is the matrix A, which is having dimension m cross n. Now this matrix can be represented as sum of three matrices. So what are those three matrices? A 0 0 0 going up to 0, and then we have this a21 0 0 going up to 0, and then we have this a1 sorry am1, am2, and this will be am and minus 1, and then this will be 0. So here we will have a31, a32, but this will be 0, plus matrix a11 0 0 0 0, a22 0 0 0, a33 0 0 0, amn. This is a diagonal matrix, and the third matrix will be matrix a11, a12, a1n 0, sorry, this will be 0 0 0, and then a23 going up to a2n, and then we will have this s 0 0. So basically this matrix A is taken as summation of this lower triangular matrix, that is this matrix, then this diagonal matrix, that is this diagonal matrix, and the third matrix is this matrix, that is upper triangular matrix. So this matrix system Ax is equal to B is written as L D plus U x is equal to B. Now I am doing some rearrangement, that is D times x is equal to L plus U minus x plus B. So I can say that xk plus 1, this is the new value of vector x d, is equal to minus L plus U xk plus B. That means xk plus 1 will be nothing but minus L plus U. This will be nothing but minus D inverse L plus U, the value of vector at x at previous iteration, plus D inverse times B. So D is nothing but, D inverse is nothing but, this is nothing but 1 upon A11, 1 upon A12, sorry, A22, and this is 1 upon AMN, and this will be 0. So this is D inverse, because since D is uh, a diagonal matrix, so inverse of that will be the inverse of elements, diagonal elements. So essentially we can say that this x, the value of x at uh, new iteration is nothing but minus D inverse L plus U times the value of vector x at old time step plus B vector. Now if we write down this Ax is equal to B in the form of this summation, where Aij xj is equal to Bi, where j is going from 1 to n and I is going from 1 to m. So from this we can write down this, that xj at k plus 1 is nothing but, is nothing but Bi minus summation of j is equal to 1 to n, where j is not equal to I. So this is basically xi, this is xi k plus 1 is Bi minus j is going from 1 to n, where j is not equal to I, Aij x at old time step divided by Aii, and this method is called Gauss Jacobi method. So what did we learn from it? That we have a guess vector xk, find vector xk plus 1 using xk plus 1 is nothing but Bi minus summation of j is equal to 1 to n, where j is not equal to I, Aij xj k. This value will come from here, and then we will have Aii, and then the third step will be xk plus 1 minus xk mod. Since these are the vector, then we will take the mod of this is less than epsilon, where the epsilon can be 10 to the power minus 10. So this can be the convergence criteria. If it is true, then xk plus 1 is the final solution, and if it is false, then xk plus 1, then xk will become xk plus 1, and we will go to this step. So this is basically the pseudo algorithm of this this method. This is called Gauss Jacobi method. This is Gauss Jacobi method. So I will show you the expanded form of this method in the next video, and then subsequently we will talk about the Gauss Seidel method. Thank you.